Hello M3, this is Teacher Win and welcome to another lesson in science which is about polymers. The topic or lesson for this video will cover pages 113 to 122 of your science book. For our warm-up, let me ask you, what do you think are this? What do you think are they made of? Okay, very good. So it is made of plastic. So what are plastics? So what are plastics? So they are a group of materials, either synthetic or naturally occurring, that may be shaped when soft and then hardened to retain the given shape. So if we talk about synthetic, it means man-made. And if it is natural, so from the word itself, nature. So they are, or they occur in nature already. We're in these plastics, so they are shaped. So basically, so if it is hard, so you have to melt it and then shape it into the desired shape that you want. Also, with your plastics, so they are also examples of your polymers. Say it again, polymers. So what are polymers? A polymer is a chemical substance with large molecules made from simple units called monomer. So if you can still remember molecules, so they are a group of your atoms. So in this polymer, so you are connecting this atom to make into molecules, and then these molecules are connected or chained into a longer molecules, which is now your so-called polymers. So it looks like this. So this is like a group of your simple molecule, which is called your monomer. So we're in to make your polymer, so you're going to make several monomers to be connected to become a polymer just like this one. So for our example, so we have at least 4 monomers connected together and you have your polymer. Okay, now speaking of your polymers, so we are going to classify these polymers according to the origin or the beginning of a material, according to the type of monomer, and also with the chemical structure of these polymers. So for this part, let's begin first with origin. So origin of polymers can be classified into 2 parts. Number 1 is your natural polymers. So basically, so they are chemically processed within a living organism. Please take note, a natural polymer, it comes from a living organism. So like for example, so we have your DNA, your rubber, which is from a rubber tree, and then your cellulose from your plant, and also your wool from your animals. So like for example, we have there your sheep. Another origin of polymers, so we also have your synthetic or your man-made. So they are chemically processed inside a laboratory. So they use chemicals to combine, so to make a polymer stronger or better than the natural polymer. So we have here examples such as your nylon, you have your polyester, Teflon, and also your epoxy. Okay, now let's go to the second classification of polymer, which is your according to the type, okay, or the type of monomers. So there are two kinds or two types of polymers here. So we have your homopolymers, and copolymers. So if you talk about homo means like one or the same. So if you look at our example here, so as you can see, it is a chain, but if you look at the letters, so all of them is made up of the same structure or the same component, which is all letter A and which has the same color, which is also color blue. So these examples of your homopolymers, so something like your sugar or your glucose, so they're example of your homopolymers. And if you talk about your co meaning like cooperation, or you work together, or you combine with another one. So copolymers, so you combine different homopolymers to have your copolymers. So with our example here, so you have A, B. So B here is another monomer which is combined to the monomer A to combine or to have your copolymer. So our example here can be like your protein. So your protein or proteins which are used for muscle building, so they're example of your copolymer. And finally, we have your third classification of your polymer, which is according to its chemical structure. So there are three kinds of chemical structure under your polymer. Number one is you have your linear. Number two is your branch chain, and cross link. So I will be discussing this one by one. So let's begin first with our first polymer structure, so which is your linear. So linear from the word itself, line. So they are like polymers in just one long chain, which is a straight line. So what are our examples of your linear polymers? So number one is we have your PVC or your polyvinyl chloride. So your PVC, so if you look at our pictures, so it is like a water tube, so which is commonly used in buildings or homes to connect water water pipes. So wherein it allows your water to flow going to your sink or to your kitchen or to your toilet. Okay, next we also have your polyester. So your polyester. So which is an example for this is like your styrofoam, so which is commonly be seen like for food package or food containers, right? Especially right now we have COVID, so most of the foods are eaten outside the restaurant. So this polyester or your styrofoam are used to pack the food. Okay, and then the third one, we have your high density. We have your high density polyester. So your high density polyester or HDPE. So this is like a stronger version of your polyester. So as you can see, so these are commonly found like the water pipes or like the main pipes that is used to like to connect or to bring water to different houses or to different establishments. Okay, so that's all about the linear polymer. Okay, the next type of polymer is we have your branch or branch chain polymer. So basically it's just like a linear polymer. However, in your linear polymer, there is like a small bumps or small branch structure that looks like this. Okay, so basically in your branch polymers, so they are not very close to each other. So the good thing is that they are flexible, they are versatile, and however, their melting point, so when you heat them, they melt very quickly. So that's the disadvantage or not the good thing about this branch polymer. So if we look at our examples, so you can see here we have plastics, right? We have plastic, we have your plastic roll, or even your plastic bottles. So they are examples of your branch polymer. So wherein they are very flexible, so you can bend it or you can crumple it. However, if you place them in a heat, they will melt easily. And the final type of your chemical structure of your polymer is we have your cross-link. Cross-link. So it's like a linear polymer wherein there are bumps, which is your branch polymer. However, this bump, they meet at a certain point. Okay, so they meet at a certain point. So meaning these two branch polymers, so they are now connected to each other. So this is what you call your cross-link polymer. So in your cross-link polymer, so they are like a long chain of your branch polymer, wherein the good thing of this kind of polymer is that they are strong. So they are strong and high resistant to heat, so they don't melt easily. So when you use them to cook your food, okay? So, however, if you heat it further, if it is very really hot, then they will possibly break. So what are these examples of your cross-linked polymers? So you can find them at the common household utensils like your plate, like your cup, like your spoon, or your plasticware. And also even for cooking. So you have here on this side. So for this side, so these are examples of your melamine formaldehyde. Or your MF. So you can basically find this one in your 20 baht shop. So they're very easy to use. They don't melt easily. So like for example, when you are like cooking your food and then you want a container, so basically you can use them because they don't melt easily. And another one is we have your Bakelite. We have your Bakelite polymers. So if you're fun with cooking, so you can find them in your handles, okay, or in on top of your lid. So this one, so they can resist high heat, so they don't melt easily. So which is best for cooking. Okay, so we cannot deny that polymers are very essential or very important to our lives. So since it's very important, so we are going to classify them according to the uses or the common uses. So number one is you have your plastics, so you can find it there. You have your rubber and also your fiber. Plastic, rubber, fiber. Okay, speaking of your plastic, so actually it comes in two types. Number one is we have your thermoplastic. Thermoplastic. So thermoplastics, that's the first type. The second type is your thermoset. Thermoset plastics. So let me have first your thermoplastic. So thermoplastics are examples of your linear and branch polymers. So the good thing is that they are high resistant to impact, meaning if you drop them, they don't break. And then if you pour like vinegar or any simple chemicals at home, so they don't react, so they don't change color. And the good thing of these thermoplastics is that they can be shaped and recycled many, many times. Okay, and it can be melted as well, right? So that's why for your thermoplastics, so any plastic that will melt easily, and then you can shape it like your plastic bottles. So they are examples of your thermoplastics, easily to melt. So, however, you cannot use them in cooking because they melt easily. Okay, the second type of your plastic is you have your thermosets or your thermoset plastics. So these are examples of your cross-linked polymers. So wherein they are very high resistant to impact. So again, they don't break easily when you drop it, and then they have high resistance to heat. That's why you can commonly find them in cooking or electrical appliances because they don't melt easily. However, so when you melt them, they cannot be or it's difficult to shape them again into its previous structure because this is an example for cross-linked polymer. So please take note now. So even if it is high resistant to heat, still they can be broken if you are going to expose them to a very high temperature. Okay, so like for example, when you buy the thermosets material, like for example for cooking, like your Teflon or your Bakelite products, so if it says there not more than 300 degrees Celsius, however you cook them, you put them in an oven, shall we say you cook or put them in 400 degrees Celsius, so they will melt. because they are over the desired temperature, which is like your 300 degrees Celsius. Okay, so let me just share to you some common plastics that you can find at home. So number one is your PVC again, or your polyvinyl chloride. So this polyvinyl chloride, so the good thing is that they are resistant to chemicals. That's why they are commonly used as your water pipes, because they don't react with any chemicals that might run through the water pipes. Also, so they are resistant to moisture, so meaning they don't get rust. So rust is like in your metal when you expose it with oxygen and water, so they turn brown. So with PVC, so they don't turn brown, which can affect the quality of your water. And also they are hard also, so they are tough, so which makes them a good product as your water pipe. Okay, so PVC can also be found in your wires or your floor tiles at home or other chemical containers. Okay, number two is we have your polytetrafluoroethylene or PTFE, or polytetrafluoroethylene, or to make it simple, we call them, or commonly known as your Teflon. So Teflon are very common in cooking products because especially in frying, because they don't melt easily, and also they are strong, they are tough and resistant to chemicals, and when you drop them they don't break easily. So that's why Teflon is also very good in cooking, because if you tried cooking, especially fried food, so after cooking, so you might notice, oh, it's very hard to remove this one. Like for example, you're cooking pork and you're or cooking fish. So in ordinary pan, so when you cook them, there are like brown stains here, which is difficult to remove. However, with your Teflon, Teflon is slippery. So Teflon is slippery, so this one, so after cooking, so you cannot find them. Okay. Next, we have your polyurethane, polyethylene, and polystyrene. So polyurethane, polyethylene, and polystyrene. So they are commonly found in your styrofoam, or maybe your food container. So wherein they are very good to use because they are soft, light, light meaning not heavy, and then versatile, so meaning you can design or you can use them in different purposes. And then also they are also like resistant to heat, but not too high or else it will melt. So like for example, like your favorite cooked food, so you're going to place them as your takeout food so they don't melt easily. Okay, the second use of your polymer is we have your rubber. So for number one, so we have your natural rubber, and then number two is your synthetic rubber. So for your natural rubber, so I think you just imagine rubber like your rubber band. So they are elastic. Elastic meaning they can be stretched. So and then resistant to tension. So resistant to tension meaning they don't break. Okay? Since they are stretchy, they are elastic. Also, please take note that they becomes soft yet hard. So something like when you are going to heat them. So if you're going to mold or design a product using a natural rubber, so it is best to design them or mold them when you heat them because they are soft and easy to mold. However, if you let them cool, so it will be hard to make it or to form it or to design it. Okay? And however, in your natural rubber, so it becomes brittle. So this is like brittle, so break, or like for your rubber band. So rubber band, so if it is in a warm place, so when you stretch them, it's easy to stretch them because they are elastic when it's warm. However, if you place them in a cold environment or maybe in a fridge, and then maybe after like 1 hour, and then you remove the rubber band from the fridge, so try to stretch them and it will break. Okay, because that's the characteristic of your rubber. They break easily when it is cold. Okay, so also in your natural rubber, so natural rubber, they come from the trees or the rubber tree. So basically they are in liquid form, so you cannot use them immediately. So you have this process so-called your vulcanization. You have this process of your vulcanization. So we're in you combine chemicals to make the natural rubber more stretchy, more resistant to tension, okay? And at the same time, it will become insoluble, meaning when you place it in a water, they don't mix with the water, okay? So that's what you call your vulcanization process, okay? So usually, so the common chemical that they will add there is your sulfur, okay? And then after that one, with your vulcanization, so they're going to heat it again, okay? And like for example, in your like your tires, so adding sulfur, heating them, so you have your vulcanized rubber. Vulcanized rubber. Okay, so where can you find this vulcanized natural rubber? So we have your rubber bands, your tubes, even your gloves. So you can find them in your natural, or you can find natural rubber in those products. Okay, number two is we have your synthetic. Synthetic meaning man-made or artificial. So this synthetic rubber is like better than natural rubber because they are more resistant to abrasion, meaning they don't easily scratch, and then they are more elastic even at low temperature. Remember that in your natural rubber, if you place them in a cold area, they break easily, right? However, in your synthetic rubber, even if you place them in a very cold place, so they don't break. Also, so something like your synthetic rubber is like an improved or better version of your natural rubber. So in your synthetic rubber, so we have examples, polybutadiene. So you can find it in your tires. You have your styrene butadiene. So we have here your, you can find it at the soles of your shoes. And then we also have your acrylonitrile butadiene, acrylonitrile butadiene for pipes and automotive parts in your cars. And then finally, the third use of your polymer is we have your fiber. So fiber comes in two types. You have your natural and also your synthetic. So let's begin first with your natural fiber. So meaning you can find them in your living organism. So it can be a plant fiber and your wool fibers. So this one, so these pictures are example of your plant fibers. And this one are examples of your animal fibers. So I believe that Thai people, so you have your own animal fiber from your silk, right? So which is a very good quality for export or selling them outside the country. So that silk product is an example of your natural fiber. Okay, and then finally we have your second type of your fiber, which is your synthetic. So synthetic, so meaning artificial, so you add chemicals in order to have different results. So like for example, so like your nylon are your polyamide. So they are used for your clothes, your socks. So this one. So your clothes, your socks, your tights, or hair brushes, or your strings. Okay, what else? You also have your polyester. So your polyester can be used in ropes or fishnets. Okay, and other synthetic fibers. So normally in your synthetic fiber, so they are very good because they are waterproof and resistant to chemicals and wrinkles. So meaning if even if you don't iron them, so even if you don't heat them, so like for example your clothes, so you are going to wear them like for example the next hour. So and you see that your clothes has folds. So even if you don't iron them, so you can immediately wear them because they are resistant to wrinkles. Okay, so finally we will answer your workbook altogether. So please open it to page 123. Okay, so the instruction here is to tick or check the correct statement and cross out and change it into a correct one. So number one, so a polymer is a chemical substance with large molecules made from multiples of smaller and simpler chemical units called monomers, bonded together in long repeating chains. So number one is like a combination of monomer is what you call your polymer. Is it true or false? So it's a true. So you're going to check this one. Okay, number two. A cross-linked polymer is soft when heated and hard when cool. Okay, so again, so example of your cross-linked polymer are your cooking materials like your Teflon, your your melamine formaldehyde. So they are example of your cross-linked polymer wherein if you're going to heat them, so they are still hard. So meaning it's not a cross-linked polymer that is getting soft when heated and hard when cooled. So basically, so they are your linear. So I'll just, you can do it like this. So erase this one and change it into linear and branched polymer. Okay, number three. So proteins can be classified into natural polymers and homopolymers. So number three is also a mistake. That's because yes, it's true that your protein comes from a living organism, so it's a natural polymer. However, your protein is an example of your copolymer. Okay, number four. Natural and synthetic rubber is vulcanized before used. So meaning, are you going to add chemical? Are you going to heat them before using them? So actually, so yes or no? Okay, so we are going to vulcanize them na to make them stronger, more resistant to heat, more resistant to low temperature, more resistant to scratches, right? So in short, you're going to vulcanize them, you're going to add chemicals and heat them to improve their function. Number five, okay, natural fibers are resistant to chemicals and tolerant to mildew and microorganism. They cannot absorb water well. So what do you think? Okay, so the answer is X. Okay, why it is an X? So actually na your natural fibers come from your animal fiber and plant fiber. So they are more of absorbent. So meaning they absorb water well. So you can just erase this one. So they absorb water well. And also they are not waterproof because your waterproof are your synthetic fibers. And another thing is that since they are from your plant source or your animal source, so you don't use chemicals to make them better. So meaning, so they are sensitive. So they are sensitive to chemicals. Okay, to they're also not tolerant to mildew and microorganisms. Okay, for number two, so let's try to match the numbers to its corresponding letter. So what do you think is an example of your natural fiber? Okay, so the answer here is your letter B, your flax. Flax, it's an example of your plant-based fiber. Okay, number two. So you have your polyethylene monomers. So we are looking for the simple form of your polyethylene. So the word poly means many. So many ethylene. So we are looking for the monomer of your polyethylene. So we are looking for the word ethylene, which is letter D. Number three. Fibers that are tolerant to microorganisms and dry quickly after washed. So we are looking for a synthetic fiber. So synthetic fiber are said to be waterproof, so they don't get easily damaged by bacteria or microorganisms. So we are looking for the nylon. So nylon, or letter A, is an example of your synthetic fiber. Number four, so we are looking for a half-breed, or like it can be synthetic or it can be a 50% synthetic, 50% natural, so it's a combination. So we are looking for a cellulose, okay, acetate, or letter E. And finally, we're looking for example of your natural rubber. Natural rubber. So we are looking for a letter C, which is your polyisoprene rubber. Okay, M3, so this is the end of our lesson for this video. So I hope you learned something. And if you have questions, so please message Teacher Bean. So once again, so thank you very much for listening and have a nice day, M3. Goodbye and stay safe always.